Come back to the class. So we have a system of equations problem. Now we have x squared minus y squared equals 24. Now let's call this equation 1. Okay. And then we have xy minus 35. Let's call this equation 2. Now from equation 1, we can apply difference of two squares, or we can apply difference of two squares in equation 1. Okay. Now a squared minus b squared should give us a plus b times a minus b. Okay, so we can apply this to equation 1 and then have x plus y times x minus y equals 24. All right, now let's square this and then square here. Okay, all right, now we are going to apply the product to a power rule of indices. That is, if you have a times b exponent c, this gives us a exponent c times b exponent c. So you're going to have x plus y exponent 2 and x minus y exponent 2 equals 24 squared. All right, now let's apply the square of a binomial property here. Okay, so if you have a plus b squared, this equals a squared plus 2ab plus b squared. Okay, so our equation becomes x squared plus 2xy plus y squared. And then here we have x squared minus 2xy plus y squared equals 24 squared. All right, so this is what we have. Now, from equation 2, okay, from equation 2, xy is given as 35. So wherever we see xy in our equation, we put 35. All right, so you're going to have x squared, okay, plus 2 times 35 plus y squared, okay, and then here you're going to have x squared minus 2 times 35 plus y squared equals 24 squared. All right, so our equation becomes x squared plus 70 plus y squared times x squared minus 70 plus y squared equals 24 squared. All right, so this is what we have. So we can rewrite our equation as x squared plus y squared plus 70, okay, and then here we have x squared plus y squared minus 70 equals 24 squared. All right, now from difference of two squares, okay, a plus b, a minus b, a plus b times a minus b can be written as a squared minus b squared. Now compare this to the equation, and then you can see that we can write, okay, x squared plus y squared, okay, squared, okay, minus, okay, 70 squared equals 24 squared. All right, so we have derived this from our equation using difference of two squares, okay. All right, so you're going to have x squared plus y squared square equals 24 squared plus 70 squared, or 70 squared. Now this gives us x squared plus y squared all squared equals now 24 squared, okay. So let's see. All right, so 24 squared gives us 576, and then 70 squared gives us 4900, or 4900, okay. So you're going to have x squared plus y squared all squared equals, now 576 plus 4900 gives us 5476, okay, 5476. Okay, so this is going to give us x squared plus y squared equals plus or minus the square root of 5476. So you're going to have x squared plus y squared equals plus or minus. Now this gives us 74. Okay, so we have two cases in this equation. Therefore, you can say x squared, let x squared plus y squared equals 74 be equation 3. Okay, and then x squared plus y squared equals minus 74 be equation 4. All right, now the question asked us to find x plus y. So now we want to find x plus y, okay? So we say finding x plus y. So we say, okay, we quote another identity, the square of a binomial identity. Now, a plus b squared should give us a squared, okay, plus 2ab plus b squared. Okay, therefore, x plus y squared should give us x squared plus 2xy plus y squared. Now let's use this to solve our question. Okay, so let's apply equation 3. So from equation 3, okay, from equation 3, the value for x squared plus y squared is 74. Okay, so we can say, before we apply equation 3, let's group the terms of the expression. Okay, let's group the terms of the expression here to take the form of equation 3. Okay, so we are going to say x plus y squared equals x squared plus y squared, okay, plus 2xy. Okay, so you can see from equation 3, we can substitute this. Okay, we can put this value, we can put the value for x squared plus y squared here. Okay, so we say from equation 3, okay, x squared plus y squared equals 74. So we're going to write 74 plus, now from equation 2, okay, let's do this. So we say from equation 3, x squared plus y squared gives us 74. Okay, and then from equation 2, okay, xy gives us 35. So you say put equation 3 and equation, okay, now let's do some checks here. All right, so this is not equation 3. Okay, so let's say from all right, so it's correct. So you say from equation 3, okay, all right, so what we did, let's focus on what we did. All right, so this is what we have. Now let's put equation 3 and equation 2 into our expression. Okay, so our expression is, okay, x plus y squared equals x squared plus y squared plus 2xy. So we're going to have, okay, x plus y squared equals, now x squared plus y squared is 74, okay, and then 2xy will give us 70. So we're going to have x plus y squared equals, this gives us 144, okay, so we're going to say x plus y equals plus or minus the square root of 144, okay, so we're going to have x plus y equals plus or minus 12. Okay, so the first one is going to be x plus y equals 12. Okay, and the second one is going to be x plus y equals minus 12. So you can say x plus y equals minus 12, or x plus y equals, x plus y equals 12, or x plus y equals minus 12. Now, we are supposed to solve the other equation, okay? So let's go back and reference that equation. All right, so we say from equation 4, x squared plus y squared equals minus 74. Okay, so we say from equation 4, x squared, okay, plus y squared equals minus 74. All right, so let's apply the square of a binomial identity. So we are going to have x plus y squared equals, okay, x squared, okay, plus 2xy plus y squared. And this gives us x plus y squared equals x squared plus y squared plus 2xy. So let's do the substitution. And then we have, okay, x plus y squared equals minus 74 plus 2 times 35. All right, so this will give us x plus y squared equals minus 74 plus 70. So we're going to have, okay, we're going to have x plus y equals plus or minus, you're going to have x plus y squared equals minus 4. Okay, so you're going to have x plus y equals plus or minus the square root of minus 4. All right, so our equation becomes x plus y equals plus or minus, this is the same as 4 times minus 1. Okay, so let's apply sets here. So if you have a, the square root of a times b, this equals the square root of a times the square root of b. So our equation becomes, okay, x plus y equals plus or minus the square root of 4 times the square root of minus 1. Okay, so you're going to have x plus y equals plus or minus 4, or the square root of 4 is 2. All right, now we know that, okay, we know that minus 1 is the same as I squared. So in place of minus 1, we can write I squared. So we can say x plus y equals plus or minus 2 times the square root of I squared. All right, so this I cancels this. So you have x plus y equals plus or minus 2i. Okay, so we are going to have two values for x and y, s plus y here. Okay, s plus y, not xy. So you're going to have x plus y equals 2i, or x plus y equals minus 2i. Okay, all right, so when you take s plus y, now we have four values. Okay, we have the one we had here. Okay, we have the one we derived using, okay, using equation 3, and then we have the one we derived using equation 4. So in all, you have four values for s plus y. All right.